Now I'll try to explain phase contrast microscopy. It is extremely difficult, so I won't be able to give you more than a glimpse of it. But we can start looking at the condenser now. You can see we can lower it and take it out, but don't do that yourself because it's hard to get it right again. You can take it out, and it has a range of settings that you can that is more easy to see if you look at it from this direction. You can turn it around, and if you look at it first, the first setting is just the open, and if we can look at it in close, you can see we can close an aperture almost totally, and but that's only possible in the first setting. If we go to pH 1, you can see we have a very, very small ring where the light can go through. If we go to pH 2, there's a larger ring, and if we go to pH 3, there's an even larger ring. The last one is not used in what we are doing. So I'll try to show you here with a little gimmick I made. I took some. If we take some paper, we can try to see what the condenser does with the light without doing actual microscopy. If we now lower or raise the condenser, you can see the light start focusing because this cone of light, we can make that smaller and smaller and smaller. And this is actually almost like it would be if you have if it's correctly, and you can see the aperture clearly down in your ocular. But now if we change this one to pH 1, then you can see we can go up and we can actually make it extremely small, this end of the cone of light. But what we now is about to show is that if you actually bring it down, then you'll see that it's actually not just a uniform light source, but you can see it actually comes out as a ring. And this is exactly what we are trying to show you, because this ring is actually the clue to how phase contrast microscopy works. When we illuminate through this ring aperture, the cone of light will be smaller and smaller until it hits the specimen, and then it'll be projected up into the ocular afterwards. But when we look at this, it's only the ring of light that goes through. But when that is projected up into the objective, it will meet a ring of a graded material that will actually slow down the waves of light so that they will be half a period slowed down, and that means that what was before a positive wave will actually end up being a negative wave. And if these two, the negative wave, if these two meet each other, they will annihilate each other. But if something now sits in where the specimen is on top of the cone of light, and they're reflective, then the beams of light will not go straight through the rim, but they will be mirrored away, and they will end up in other places. So they will, for instance, move in totally different directions, but end up in the same place. And then if you have direct light that will go to the same place, then we have positive and negative light that will annihilate and end up giving black, no light. And that is why you'll see bacteria as black, small black spots when you phase contrast, because black is reflective surfaces, but else everything is white.